We're going to talk about even and odd functions today. So one of the ways that we can do this is actually visually. And I think this will help you on the ACT test if you're preparing for that, and maybe as a quick check if you're unsure if your answer is correct based on the algebraic work. So there are two methods. So I'm going to show you how to determine if a function is even, odd, or neither visually. So if you have your graphing calculator, go ahead and go to y equals so that we can insert a graph. Make sure everything's blank, there's nothing weird highlighted or pocket dialed all the way down here at the bottom, because then you'll get an error message. So in our first equation, what we're going to do is we're going to go ahead and plug in negative, so you have to use the negative button. We're going to say the absolute value, and so in order to pull up the absolute value, you need to go to Math, go to the right one under the number section. You see how it's highlighted already as absolute value, so ABS. We're going to hit enter. You can either hit enter to select that, or you can hit the number 1 to select that. Now, within your absolute value bars, we're just going to put the letter X. So that is this button right here. Then go outside of the absolute value bars, and we're going to plug in +2. So the negative absolute value of x +2. Go ahead and hit graph so we can get just a visual of what this looks like. So we know that the negative makes the absolute value bar flip. We know the +2 makes it go up 2. But that's not what we're worried about right now. We're trying to determine, is this an even function, an odd function, or neither? So what I'd like you to write down is that an even function reflects over the y-axis. So here is our y-axis. So the reason this is an even function is because if I could fold this paper or this board over the y-axis from the left side to the right or from the right side to the left, if I fold on the y-axis, the right side of the graph lands on the left side of the graph. So this is an even function. Now there's a way to do this algebraically, but this is a quick visual to see, hey, if it's symmetric about the y-axis, meaning I can fold it along that y-axis and the left side lands on the right side, then it is an even function. So in this case, this is an even function. Let's take a look at what an odd function is. It's a little harder to show visually and explain. But let's go ahead and go back to y equals, clear this out, and we're going to type in 2 divided by x. So 2 divided by x. Once you get this, you're going to go ahead and graph that to see what this looks like. Now, notice how we have kind of 2 pieces here. And we have these asymptotes, a horizontal and vertical asymptote that we're not going to worry about right now. But how do you know something is an odd function? So odd starts with the letter O, and so does the word origin. So odd function reflects about the origin. So O goes with O, odd goes with origin. And how you do this is if you could take your calculator and you could take a mental picture of what this graph looks like, and then you turn that calculator upside down, and your picture looks the same right side up as it does if we were to flip this upside down, then that means it is an odd function. Now it has to look exactly the same. So for example, notice how if we're in quadrants, this is quadrant 1 and 3. If I could take this screen and I could flip this upside down, I would still be, this quadrant 3 would come to quadrant 1 would come to quadrant 3, and the shape of the graph would still be the same. Therefore, it reflects about the origin. So this is an odd function. So odd goes with origin. Notice how it's not an even function, because if I were to fold this over the y-axis, the left side and right side would not land on top of each other, right? So it's not an even function. We're not going to show an example, but there are examples of functions that are both even and odd. So for example, a circle. If we graphed a circle with the center at the origin, that would not only fold over and be symmetrical about the y-axis, making that even, but if we flip that upside down, it would also be odd. Finally, what about functions that are neither either even nor odd? We're going to take a look at one of those. So go back to y equals and clear this out. Let's just do a log function. So go ahead and type in 2 times the log of x. You can close your parentheses, but you don't have to. I'll do it to make you feel better. And so when we graph this, what we see is that this is neither even nor odd, because we can't fold this over the y-axis and have it land on itself. And if I take a mental picture of this and turn it upside down, it's not going to look the same upside down as it does right side up. In fact, most of the functions that we deal with in class are going to fall under the neither category. So just remember, a quick refresher, that even functions reflect about the y-axis. Odd functions, because it starts with an O, reflect about the origin, which also starts with an O. And then neither functions would be neither even nor odd. So they don't reflect over a y-axis, nor do they look the same right side up as they do upside down.